Electromagnetic force is the basis of all chemistry and matter on Earth. It is the interaction of electric fields and magnetic fields. It was one of the parameters that emerged from the Big Bang during the Planck epoch, forming the grand unified force. This happened at 10 to the negative 33 seconds. The inflation period of the Big Bang that occurred faster than the speed of light. Someone may ask, so if Einstein's theory of relativity gave us the idea that nothing can move faster than the speed of light, how come the inflation period was faster than the speed of light? The answer is, Einstein said that it was information that could not travel faster than the speed of light, but space itself could. Cosmic inflation occurred faster than the speed of light. At 10 to the negative 32 seconds to 10 to the negative 12 seconds, electroweak force was still existent, and the universe was made up of only quarks and gluons, making the quark-gluon plasma. It was after this time the temperatures cooled down for the two forces to split, and we had the electromagnetic force and the weak nuclear force. Now, what is the electromagnetic force? Scientists of old discussed and came up with their various findings about a charge and its movement. We were taught that Alessandro Volta defined electricity, which is the flow of charge, as electric current generated by contact between different metals. This led to the making of the first battery. Augustin Charles de Coulomb stated that the attractive force between two oppositely charged spheres is proportional to the product of their quantities of charge on the spheres and is inversely proportional to the square of their distance between the spheres. André-Marie Ampère then carried out an experiment showing that two parallel wires carrying electric currents attract or repel each other, depending on whether the currents flow in the same or opposite directions. Faraday found that if he moved a magnet through a loop of wire, an electric current flowed in that wire and vice versa. This experiment established that a changing magnetic field produces an electric field. A mathematical formulation now recognized as Faraday's law. Faraday also proposed that electromagnetic forces extended into empty space around the conductor. That's the concept of lines of flux emanating from charged bodies and magnets. The Biot-Savart law talks about the creation of magnetic fields due to current elements. Ampere's law explains that an enclosed current is the total current that passes through the surface bounded by a closed path of integration. All these are interesting theories of these phenomenal scientists of old. What then is a charge? A charge is a basic property of matter, just like mass. Humans cannot directly sense charge, but some animals can with electroreceptors, such as the ampulla of Lorenzini of a shark. We can observe charge indirectly through its effect on matter. A charged particle creates a field in all space. A combination of two electric charges with equal magnitude and opposite sign, separated by a fixed distance, is called a dipole. Magnetic dipoles also exist, and they can create magnetic fields. Magnetic fields points away from north and towards the south. The Earth's magnetic field has a magnitude of roughly 0.00005 Tesla. A powerful permanent magnet, like the kind you might find in headphones, might produce a magnetic field of 0.1 Tesla. You see the comparison. Don't get me wrong, but you have a powerful magnet in your ear, powerful than the whole earth. Yeah. Magnetic flux is a number of magnetic field lines passing through a surface. Mass spectrometers separate charges of different mass. When ions of fixed energy enter a region of constant magnetic field, they follow a circular path. The radius of path depends on the mass to charge ratio and speed of the ion and the magnitude of the magnetic field. The magnetic force on a charged particle is given by F equals Q vector B cross vector B. The merging of these two scientific giants in terms of theories began their journey when in 1862 James Clerk Maxwell calculated that the speed of propagation of an electromagnetic field is approximately that of the speed of light. The Lorentz force exerted on a charged particle in an electromagnetic field equals the electric charge of the particle times the electric field plus the cross product of the velocity of the particle and the magnetic field, like we've established earlier. Applications of electromagnetism is in galvanometers and electric motors, particle accelerators and railguns. Magnetic force is carried between objects by photons. Actually, Earth's magnetic field protects us from solar wind. It is responsible for the propagation of light. Electromagnetism is the force behind chemistry. It is indeed the driving force of life. Now, taking this from the view of scientists like Richard Feynman, gauge bosons are responsible for the four fundamental parameters. Virtual particle interaction brings about the four fundamental parameters. Photons are responsible for electromagnetic interaction. Gluon is responsible for the strong force. The W and Z bosons are responsible for the weak nuclear force, and graviton is responsible for gravity. Virtual particles are particles that exist due to Heisenberg's uncertainty principle. These are particles that nature creates by borrowing energy from vacuum, and this is the vacuum energy I talked about some episodes ago, and then destroying this matter created before it could get detected. Someone could ask, if we can't detect it, how then do we know it is there? Well, this could be explained by the Casimir effect. The Casimir effect explains that the effect of a virtual particle is seen when the amount of, that's the pressure, of virtual particles outside two closely held plates is greater than the amount of virtual particles or pressure within the plates, and this creates a physical force. So the particle and antiparticle creation and annihilation occurs via the virtual photons. The exchange of these two particles is what causes the physical force. For example, when two magnets attract and repel each other, it is due to the exchange of these virtual photons. Negative momentum is what attracts two unlike charges together, and positive momentum is what causes two charged particles to repel. For example, When you are standing on a boat with another person and you throw balls to each other, as you throw the ball, force will push you back, drifting you away from the person you are facing. This creates a positive momentum. Now you are standing against each other, facing opposite to each other, and then you throw the ball. Forces push you together, creating a negative momentum. When charges are equal, the virtual particles within are of a higher energy state, and since particles naturally prefer being in a lower energy state, they repel these two particles and vice versa for the particles of opposite charges. The higher the mass of the particle, the shorter the distance it could travel. Heisenberg's uncertainty principle states that the change in energy multiplied by the change in time equals Planck's constant divided by 2 pi. Virtual particles can exist if the energy multiplied by change in time is less than h over 2 pi. And since for far interacting objects require enough energy for interaction, the electromagnetic effect is a short distance effect as compared to gravity. So ladies and gentlemen, this is what we have for you for electromagnetism. Until next time, this is Einstein in a flash. Like and subscribe. Bye bye.